String theory. To be explained in physics, string theory is a relatively modern concept of the quantum world. It states that subatomic particles, for example quarks, can actually be broken down further into what is known as strings. But how exactly do these one-dimensional strings work? Well, quantum physics states that the only effect of the strings can be observed in our dimension is the fact that they vibrate at different frequencies, and thus the diverse masses, charges, and other characteristics of particles can be created out of sheer string vibration. Physicists also say that strings are responsible for gravity, electromagnetism, the strong nuclear force, and the weak nuclear force. However, string theory is still largely unconfirmed, and there are still aspects of it, such as it disagreeing with relativity, a proven principle. Even so, the strings would have to exist in at least 10 to 11 different dimensions, as their three-dimensional effects, depending on how they would vibrate, can only be observed in our dimension as matter, light, and gravity. String theory has helped scientists investigate black holes, the early universe, and the Big Bang, nuclear physics, and particle physics. But how do we know string theory is actually accurate? This leads on. Because the gravitron, a particle associated with gravity, is a hypothetical massless particle that is not included in the standard model of particle physics, some scientists believe string theory could possibly be used to explain and confirm the existence of a particle that interacts and affects gravity itself. This is known as quantum gravity, which does not go with Einstein's idea of gravity. Starting from what was known as M theory, string theory is still developing, and some scientists are working on what is known as superstring theory, which states the hypothetical existence of symmetrical strings on a large scale. However, due to the chaos principle, I do not think superstrings can possibly exist in our universe or dimension.